So, let us first talk about effectiveness. So, this is emission tax, and this is tradable pollution permit. Right. Okay. So, when we are comparing the when we are evaluating these two policies, emission tax and tradable pollution permit, what is the criteria, evaluation criteria? This is, let us say, this is evaluation criteria. So, the first evaluation criteria is, let us say, effectiveness. Okay. And what I told, that effectiveness depends on objective. Now, let us assume that policymakers' objective is to design a policy which will result in a known amount of pollution in a given period of time. So, policymaker wants a fixed amount of pollution to come out from an industry in a given period of time. So, when amount of pollution is given, pollution is fixed for a given period of time, what we know, that tradable pollution permit is, this is, let us say, tradable pollution permit or TPP in short. TPP is preferred. TPP is more effective okay, right. So, effectiveness depends on the objective, and if we assume the policymaker's objective is to design a policy which will result in a known amount of pollution in a given period of time, then tradable pollution permit is preferred compared to emission tax, because in emission tax policymaker does not know at the end how much pollution all the firms will actually generate. Okay. So, emission tax is not effective, emission tax is not effective when a regulator wants a fixed amount of pollution. This is not effective. On the other hand, let us say that a regulator's objective is not to get a fixed amount of pollution, rather the objective is to design a policy which will ensure certainty as far as control cost is concerned. Okay. So, policymaker wants when the policymaker wants, when the policymakers policymaker wants certainty over control cost, or I would say that marginal abatement cost, emission tax is more effective. Okay, because in that case policymakers design the tax rate and policymakers know that what is the control cost, marginal cost of control, that is T. But here what would be the control cost, that is unknown, there is no certainty, because policymaker has assigned the permits. Now what would be the price of the permit in the market, that is unknown a priori, that it depends on the demand and supply of permits, which is unknown actually. Okay. So that means at the end there would be lot of uncertainty about the marginal cost of abatement, because a firm does not know what would be the price of the permit in the market if I fall short of certain permits, right. In that case, if the policymaker's objective is to remove the uncertainty about the control cost, then emission tax is preferred, not the tradable permit. Similarly, when the policymaker's objective is to design a policy which will ensure a fixed amount of pollution, tradable permit is preferred, not the emission tax. Okay. TPP does not ensure certainty over cost of pollution control. Okay. TPP does not end. So these are the two alternative cases, right. And we have also discussed alternative scenarios. If you remember, alternative scenarios when the marginal benefit is known but marginal cost is unknown, then the permit, the pollution tax is more effective, because even if it is higher or lower at each point T equals to MC equals to MB is achieved. At this point, let us say this A, this is B, at both the points A and B, T equals to MB equals to MC is achieved. However, in this case, when this is known, this is M, depending on if this is MC low and this is MC high, we say that none of this point is actually effective, because once you assign proper certain permits, the permit system is not flexible enough. The permit system is not flexible enough to take additional permits back or to supply more permits in the system, as a result of which, when the marginal cost is unknown and MB is flat straight line, emission tax is fully effective while tradable permit system is not. Okay. And on the other hand, we have also discussed when this is marginal benefit is is steep straight line, and let us say this is expected marginal cost, then this is MCH, this is MC low, this is tax. So, we will say that there is a divergence between what the society wants, MB equals to MC, and what the private firm will do. Okay, what the private firm will do. So, there would be a divergence. However, in this case, when MB is steep straight line and this is MB, and let us say this is MC expected marginal cost, this is MC low and this is MC high, we say that the effectiveness of tradable pollution permit increases when marginal benefit is steep straight line. So, these are alternative cases. So, basic thing is then what we need to understand, as far as effectiveness is concerned, if the policymakers' objectives to ensure certainty over marginal cost of abatement, then emission tax is preferred to TPP. If the policymakers' objective is to get a fixed amount of pollution in a given period of time, then tradable pollution permit is preferred to emission tax. So, first we have to fix the regulator's objective, then only we can understand their relative effectiveness, right. Then let us talk about efficiency. So, efficiency, the economists they say that as long as there is perfect information about marginal cost of abatement or marginal abatement costs, both emission tax and permit system are equally effective. And at the optimum, the condition is T equals to marginal abatement cost. Let us say there are two forms, equals to marginal cost of abatement B, form A and form B. This is the optimality condition. And in case of permit system, this is in case of emission tax. And this is so we need to know what is the marginal abatement cost of each firm. Right. So, each firm is actually equating their marginal cost of abatement with the given tax rate or with the permit price. So, as long as this MAC A and MAC B, okay, marginal abatement cost, they are known with complete certainty, both the policies are equally efficient. But the challenge arises, as I said, when there is asymmetric information between the regulator and the firms about their true marginal cost of abatement, right. Now, We said here that when this is completely certain about the marginal cost of abatement, then emission tax is efficient. That means, indirectly we can say that imposing emission tax is better than imposing some kind of uniform standard. In this case, I am not asking the firms to decide, I am not asking the firms that you should abate this much and you should abate that much. Regulator is not asking any amount of pollution control from the firms. Rather, regulator is only deciding about the tax rate. Firms, they themselves, they are deciding about their respective pollution control responsibility. So, in emission tax, pollution control responsibility is not decided by the regulator, rather it is decided by the firms by equating P with their respective marginal cost of abatement. Okay, with their respective. Now, suppose instead of imposing emission tax, the regulator is equally distributing the pollution control responsibility. So, that means the regulator is asking each and every firm in that industry that everyone should control X amount of pollution abatement X amount of pollution abatement for each firm irrespective of their marginal cost of abatement. If that is the case, that is called uniform standard. So, we need to now prove that this emission tax is actually better than uniform standard as far as cost of pollution control is concerned. So, our next task is to prove that emission tax is actually efficient. So, that means if we can prove that uniform standard is not efficient, then we can actually prove emission tax is efficient and it is better than the uniform standard. Let us prove that. So, here we are discussing emission tax versus uniform standard. Let us say that we are drawing two simple diagrams. In the left hand side, this is for the firm level, this is for the firm, and this is let us say for the industry. In the x axis we are measuring emission, this is emission. In the y axis what we are measuring is marginal abatement cost. Okay. Now, let us say that there are two firms A and B, and each of them, this is let us say MAC A, and this is MAC B. So, we can understand very well that MAC B is higher than MAC A, that means B firm B is actually a high cost firm. So, B is high cost firm, and A is low cost firm. Right. Okay. And both these MACs, so that means they both are generating EFA. So, that means this is EFA and EFB. So, that means both are generating this amount of emission, okay, this amount of emission. So, for firm A, EFA is amount of emission, and for B this is EFB, right. Now, let us say that this is MAC industry level, and that is actually the weighted average of MAC A and MAC B. Let us now suppose the regulator wants this amount of pollution control, okay, this amount of pollution control, which is half of EFA plus EFB. Sorry, I will draw this diagram little differently, and instead of this, let us say that, and yeah, this is the amount. So, this is the amount the regulator, half of EFA and half of EFB is the total amount of pollution that the regulator wants to reduce. Okay. All right. So, this is the amount, OA. Let us say this O, this is O, let us say A, let us say this is B. So, half of EFA and half of EFB is the total amount of pollution reduction for both the firms at the industry level. Regulator is now, let us say, imposing an uniform standard which is given by uniform standard which is given by E bar. So, that means 2 of E bar equals to half of EFA plus EFB. So, regulator is asking both the firms A and B to reduce their pollution by amount E bar. Is that clear? So, if I take twice of E bar, then my total amount of, this is half of EFA, this is called this is total amount of pollution reduction. This is total pollution reduction. By which is achieved by imposing uniform standard E bar. Okay. Now, what is happening when the E bar amount of control responsibility is distributed among A and B? At E bar, marginal cost of pollution abatement for firm B is much higher than the marginal cost of abatement for firm A. So, at E bar, MAC B is much higher than MAC A, right, MAC A, all right. So, that means we are imposing a policy at which firm B's marginal cost of abatement is much higher than the firm A. That is why this is not a cost effective system. This is not a cost effective system. Rather, what actually we should do, if we want to achieve the same half of EFA plus EFB amount of pollution reduction, the regulator should first actually decide a tax rate decided here by equating the industry marginal abatement cost with a vertical line which is deciding about the pollution reduction. Then the same tax rate is given to the firm. Now, each firm will now equate this tax rate with the respective MAC. So, what will happen then? Firm A will reduce this much of pollution reduction. This is pollution reduction for, let us say, EA, and the pollution reduction for firm B would be EB. Okay? So, that means we can now easily understand, since at T star EA is much greater than EB. So, that means low cost firm, which implies low cost firm A abates more than high cost B, and that is why emission tax is more effective, because we are redistributing the control responsibility from high cost to low cost. Then the society is achieving same amount of pollution control at a lower cost. Is this clear? When the uniform standard is imposed, firm B's cost of abatement is much higher than firm A. So, total cost of abatement in this scenario, when uniform standards is imposed, is much higher than a situation when the tax is imposed, because when the tax is imposed, the high cost firm B is abating actually less amount. What is the amount? This is the amount. This is the amount of pollution reduction. For firm A, what is the reduction? This is the amount. This is the amount. So, firm A, since firm A is low cost firm A is abating much more than the high cost firm B, and as a result of which total cost of abatement in uniform standard, that means what we are saying, total cost of abatement in emission tax is much lower than that of uniform standard, and that is why we say that emission tax is more efficient compared to the uniform standard, because emission tax has that type of capacity to to redistribute the pollution control responsibility from high cost firm to low cost firm. Okay. Emission tax basically achieves this particular condition, T equals to MAC A equals to MAC B. So, each firm is equating their MAC with the tax rate and then deciding about their how much of emission they should reduce at optimality. But in uniform standard, that is not the case. I am asking everybody irrespective of their cost of abatement that you should reduce same amount. That is why uniform standard is not efficient as compared to emission tax. Okay. Emission tax achieves the same amount of pollution control at a much lower cost compared to the uniform standard. Okay. This is how we can actually prove the efficiency of emission tax, and same thing, same way we can prove that even tradable pollution permit is also equally efficient, but we are not discussing the same mechanism here. The only objective is to contrast this market based instrument against some uniform standard which we generally consider as command and control, because policymaker is simply fixing an amount from the outside. No flexibility is given to the firms to decide their amount of pollution control based on their marginal cost of abatement, which is the case in here in the context of emission tax. Okay. So, with this we are closing our discussion today, and remaining portion we will discuss in our next class about the incentive design. Thank you.